how do we use the fundamental theorem of calculus part 2? Well, I've picked a couple of practice examples here, and I want to, before we begin either one of them, I want to emphasize how important it is that you read what you're asked to do and respond carefully. So on number 12, you're to find a formula for the function represented by the integral. The fundamental theorem of calculus of part 2 of the fundamental theorem of calculus has to do with taking the derivative of functions that are sort of in this form, but that's not mentioned at all here. We're just to find a formula for the function represented by this given integral. Right, in number 25, we're to evaluate the derivative. So here's the evaluate the derivative, and here's our area function that we just defined right before we stated the fundamental theorem of calculus. So on this one, we use the part 2 of the fundamental theorem of calculus. On this one, we don't. So let's take a stab at the first one. This is just essentially a definite integral with one of the endpoints being variable. So that's going to be, I'm going to take an antiderivative. I'm going to use the first part of the fundamental theorem of calculus. I'm going to take an antiderivative of this function. That would be negative e to the negative t. And then I'm going to evaluate it in the notation that I use for doing antiderivative evaluated at the left right-hand endpoint minus the left-hand endpoint is this. So I evaluate first at the right-hand endpoint, then I subtract off what I get when I evaluate the left-hand endpoint, and so I use this bracket notation with those endpoints here. And I evaluate, I get e to the negative e to the negative 0 minus negative e to the negative x, which all boils down to, this guy right here is 1, because e to the 0 is just 1. And this is adding e to the negative x minus 1 because of the minus. That's the formula for the function represented by the given integral. All right, so on the number 24, to evaluate the derivative, you should probably open your book or your notes to where you can see the fundamental theorem of calculus part 2 stated. And we're looking, you guys are pattern seekers, you're looking for something that's exactly like what's in the fundamental theorem of calculus part 2, except for possibly the variable. This is stated exactly like the fundamental theorem of calculus part 2, except that s is our variable of integration. It's our right-hand limit, and we're taking a derivative with respect to s. The lower limit is constant, and so we can directly apply the fundamental theorem of calculus part 2. All that says is the derivative of an area function like this, and you should look in your text or in your notes so you can compare. The derivative of an area function of this form with respect to that upper limit of integration is the integrand evaluated at that upper limit of integration. That's that. That's it. It looks like magic, but that's what the magic that the fundamental theorem of calculus part 2 grants us.